All right, what up, everybody? Today we're talking about friction, and friction is a force that opposes the motion of an object. So the direction of friction is always going to be opposite the way that something's moving. If something is not moving, there can still be friction, but that friction will be opposite the direction that the object would move if the friction wasn't there. Okay, and so we'll see a couple examples, and you can see what I mean. So there's two types of friction. One is static friction, and that is when there is friction on something and the object is not moving. So the friction is keeping the object from moving, all right, but it's not. The object itself is not moving. Then kinetic friction is the friction an object experience, a force the object experiences when the object is moving, right? And it so happens that the kinetic friction will always be a little bit less than the static friction. So in other words, it takes more force to get something to start moving in the first place than it does to keep it moving. And you've probably experienced this if you ever tried to like push a couch or something heavy across a rug. You'll notice that you have to put a lot of force into getting it to start. But once you get it to start, you don't have to push quite as hard to keep it moving at a constant rate. So there's an equation, and the only difference between these two equations is the little subscript that they have. The S is for static, and then the K is for kinetic. And so static means it's not moving, kinetic means object is moving. But in both these equations, FF stands for the force of friction, and this little Greek letter here, it's a Greek letter mu, stands for what we call the coefficient of friction. So the coefficient of friction is a number that represents a ratio between how hard the surface has to push up on the object um, and how much force of friction the surface and the object have while rubbing against each other. So the coefficient of friction is a number that it can. There's really no limit on how low or high it can be. Anything close to zero would be a very slippery surface, right? In fact, if this was zero, then there'd be no friction whatsoever. Then anything more than 0.5 is considered a fairly rough surface, right? Uh, but they can be values above the 1 or even 2, which would be like really, really rough surfaces like sandpaper or something like that. And so, and the same thing with kinetic friction, okay? But with kinetic friction, there's a different coefficient of friction for when something's moving as opposed to when something's not moving. So for every two surfaces that rub against each other, there'll be a number that represents this coefficient for static friction, and then another number, which will be a little bit lower, that represents the coefficient for kinetic friction, right? So, like any equation, we have three variables, and if you find two of them, you can always find the third thing. So, we're going to do a couple examples, right? And again, the mu s is just the coefficient of static friction when surfaces are not moving. The mu k is when they are moving. So let's start with friction of something that is not moving. Okay, so we have the little s for static. And here's an example. Sky is trying to make her 70-kilogram St. Bernard go out the back door, but the dog refuses to walk. If the coefficient of static friction between the dog and the floor is 0.7, how hard must Sky push in order to move the dog? So you can imagine that this dog doesn't move. She's going to have to push pretty hard, especially if there's a lot of friction between the bottom of the dog and the rug. Okay, and if you ever had a big dog, you probably had to do this a couple times. So um, we need to know two out of the three variables. And remember, um, they give us the coefficient of friction right here. It's 0.7, right? Now, if we find the normal force, then we can just multiply these together and find the friction force. So that's what we're going to try to do. So use our summation statements, okay, for the vertical forces. And we know that the dog has a mass of 70, right? And gravity on Earth is about 10. So we'll just put in those numbers. Normal force is going up, so it's positive, and gravitational going down, so it's negative. And you set it equal to 0 because the dog is not moving up or down, so we expect those to be balanced, which is 700, which means the normal force is 700. Okay, so now we can use the 700 in the equation. All right, so there's our equation, right? 0.7 is the number they gave us for the coefficient of friction. So it's a fairly rough two surfaces that are rubbing against each other. And then 700 is the normal force that we just found. So if you multiply that together, you'll see that the force of friction on the dog is 490. Okay, and this is the friction of the force of friction on the dog when the dog is not moving. Okay, so now we're going to look at the horizontal forces. Again, positive forces to the right, negative to the left, and if we do that, we get that Fp minus Ff, the applied force minus the friction force, equal to 0. We know the friction force is 490, so we'll put in the 490 there, and then we can solve for the applied force, which would also be 490. Okay, so she would have to push at 490 newtons, and if she pushed any more than 490, the dog would begin moving. If she pushed any less than 490, the dog would not move. Okay. And so that's how static friction works. Let's go on and look at an example for kinetic friction, right? And in this example, she's going to push the dog at a constant velocity. So she's got him moving. And now, because it's moving, the coefficient of friction is going to change, right? And in these problems, they'll always tell you what the coefficient of friction is. But it's always going to go down once the object starts moving. So in this case, 0.5. So once again, we need to find normal force. And the normal force hasn't changed from the last problem. It's still 700. Okay, you'd find it the same way. And then you would find the force of friction by multiplying the normal force by the new coefficient of kinetic friction, which is 0.5. Okay, and you get a friction force of 350. Okay, so if you do the math again, you'll find that this guy would have to push her dog with 350 newtons of force to keep him moving at a constant speed uh, once she got him moving. So if she pushes any less than 350, then the dog is going to slow down and eventually come to a stop again. If she pushes more than 350, the dog is going to speed up. But if she pushes at 350 newtons, the dog will keep on moving. Okay, so that's an example of how the coefficient of friction plays a role in determining how much friction an object has and how easy that object is to move. All right, we'll see you all in the next video.